the conference in KNUST, we have a very huge representation. So we have become families. Any times they can rely on us and we can rely on them. I think they have gained some momentum and then some recognition in Ghana for organizing this conference in the real estate, arena and gathering, people from all universities and then from industries, speaking on the real challenges we are facing in our construction company. We want to encourage you to continue with zeal, and may the sky be your limit. And we want to thank you once again for relying on ATU to run this particular program today. ATU is actually the best destination that you can run such a program. We are the premier technical university. Clap for us. You see, when you are not clapping over here, is it that you are not proud of ATU? Me, I've not started my speech, but if you allow me, I'll go into this one first and go more. You have all reason to clap for us. A young university, even though an old institution of about 76 years, we are coming to climax our 75th anniversary very soon. But we've been a university since 2016. It's quite a young age, but we have a lot of good records. As we speak, we are running not less than about 13 master's programs to come, 23 new Bachelor of Technology programs. We have student population actually booming every day, almost 25,000 students now. And if not because of some limitation in space, this year we are going to 35,000. And I tell you, we go with quality assurance. We are not just getting volume. To the extent that we are rated 4th best university by the time higher education last year, and that is a repetition from 2022. Please clap for ATU again. On this note, I can deliver the speech. Professors, colleagues, welcome to Accra Technical University. It is a great privilege for me to welcome you all to the Viva-Industry Structural Engineering lecture today, a special lecture hosted and organized as a partnership between Accra Technical University and the Ryoko International. Today we gather to explore cutting-edge advancement in structural engineering under the theme, the hybrid approach in concrete reinforcement, exploring innovative structural solutions with fiberglass reinforcement polymer. The topic alone is exciting. I'm happy. This event signifies an important milestone in our commitment to integrating innovation with traditional construction methodologies. Let me say that as Ghana and the world move towards a more sustainable and resilient infrastructure, which we cannot deny, the need for alternative reinforcement solutions such as the fiberglass reinforcement that is proposed here has become more than imperative. We need to go into it. Because if you look in our arena, one of the most growing business has to do with construction. Concrete remains the backbone of modern infrastructures. We cannot deny that. However, traditional reinforcement methods such as the steel that we are used to continue to pose a number of challenges, among which it is easy to talk about corrosion, high maintenance cost, and then environmental. So these challenges call for hybrid approaches that incorporate durable, lightweight, and corrosion-resistant material, and this can be attributed perfectly to what we know today as the fiberglass reinforcement polymer. So there is a good reason to go in that direction. With Ghana witnessing rapid urbanization, which you cannot deny, our population is growing every day. We are adding children day in, day out, and they need to have a shelter. Our infrastructures must be stronger and more durable. We don't want to construct infrastructures that some days after we go back and condemn them ourselves. Now, if you begin to pass through some of our places right in Accra, Alajo, I don't want to mention specific areas, but you see some slums which do not befit, the beauty of a modern town and a growing town like Accra. We need to have a resilient and durable infrastructure for that matter. So innovations like FRP or a short form of fiberglass reinforcement polymer, innovation of that nature offers solutions that can significantly reduce structural deterioration, lower maintenance costs, and extend lifespan of building and bridges. Ladies and gentlemen, colleagues from RIECO, the integration of FRP into concrete reinforcement comes with numerous advantages, in my view. One of them is the corrosion resistance. Unlike steel, the FRP does not corrode, making it an excellent choice for coastal and high humidity environment. And you know we are the coast is just here. Number two, lightweight and high strength. FRP is significantly lighter than steel while maintaining high tensile strength, allowing the easier transportation and installation. Number three, enhanced structural durability. Structures reinforced with FRP exhibit increased longevity and reduced maintenance cost. And finally, number four, sustainability. With growing environmental concerns, FRP contributes to lower carbon emissions and reduce ecological footprint. So my dear people, putting together these four major advantages of FRP: corrosion resistant, lightweight material, enhanced structural durability, and sustainability, one can think far that it is just timely, it is just necessary that we begin to find a way to hybridize our reinforcement by integrating, the FRP in our doings. It will go a long way to support our development agenda and then support sustainable buildings in the future. But the question that arises out of this is that, is this actually a sustainable practice? Are we going to, if we go in this direction, are we going to get the material readily available all the time for use? Availability of material is a question. And I know the second question you might think about is cost. Yes, sometimes things are good, but if you go into it, it might be too costly compared to the conventional thing you are doing. Let me say that a key concern for new technology is cost. FRP, whilst initially more expensive than the steel reinforcement, offers significant long-term saving due to its durability and the minimal maintenance that is needed. Do you see that? So when considering the life cycle cost, FRP proves to be cost-effective alternative as it reduces the frequency of repairs and replacement. Meanwhile, initial costs might overthrow that of the steel reinforcement we are used to. Do you agree, or should I ask students? In your view, which is the most widely used reinforcement material in Ghana currently? It's a question. Civil engineering building, which of these material is mostly used as reinforcement material in Ghana currently? Yes, please. It is. It's the steel reinforcement bar. It is. However, thank you so much. I will give you a toffee. You like toffee, eh? I'll give you a toffee when I finish. Because toffee is okay. Given our tropical climate and exposure to coastal conditions, corrosions, and degradation over time, so FRP presents a viable replacement, particularly in marine structures, bridges, high-rise buildings, and water treatment plants, where corrosion resistance is essential. You agree with me? So while FRP is not yet massively available in Ghana, I must recognize that its raw material, such as glass fiber, the polymer resins, are very much accessible on the global markets. And that makes an opportunity for us. And therefore, they could be developed, for local productions. Begin to go into manufacturing if you can. Encouraging investment in FRP manufacturing will enhance availability, reduce import dependency, and promote sustainability in the Ghanaian construction sector. So, I want to bring our attention on a few things and bring my speech to a close. Let me say that this is just wonderful things to dream about. The potential application of FRP in Ghana infrastructures are vast. Some of the key areas include bridges and highway. We can go in coastal and marine substructures like port, harbor, water treatment plant, and those can benefit significantly the country. Especially when we come also to high-rise buildings. They are lightweight material. As cities expand, the lightweight nature of FRP make it suitable for high-rise construction, reducing the overall structural load. And tunnels and underground structure benefit FRP. I therefore wish quickly to make a small call for action and end these introductory remarks. As we engage in today's discussion and technical session, let us consider how we can collectively accelerate the adoption of hybrid reinforcement approaches. The benefits are multiple to all of us. Encourage all stakeholders present here, our engineers, our future engineers, our policymakers, researchers, students, to actively participate in shaping Ghana's construction industry towards a resilient and sustainable future. Let us embrace innovation, collaboration, and sustainability in our construction practices and work together to revolutionize the industry with solutions that stand the test of time. Ladies and gentlemen, the future of concrete reinforcement is here and it is hybrid. Let us seize the opportunity to make Ghana a leader in advanced construction methodologies. I wish you all a very insightful deliberation and a fruitful Viva-Industry Lecture 2025. May God be with you. Thank you very much.
Thank you very much, Prof. Acting Vice Chancellor, Accra Technical University. Prof, we are grateful. I know Prof has a meeting, so in the course of the program, he might leave. So, Prof, we are grateful. We'll start with a presentation, and then the first will come from Civil Engineering Department. The Civil Engineering Department has nominated one of our BTech students to do a presentation. So we'll call Anthony Mensah to do the first presentation. Anthony, you have 10 minutes, please. Thank you very much. You are welcome, Anthony.
Yes, good morning. Okay, as Engineer Nyamicha said, my name is Anthony Mensah, BTech top-up student, final year. Okay, so this is the project that will be carried out by Anthony Mensah and Loki Ade Launch. And this project will be supervised by Engineer David Amwa of the Civil Department. Okay, so the topic is service life reduction of buildings in Ghana, focusing on Accra as our case study. So we are going to select some buildings and some existing that to predict the service life of other existing buildings. All right, so buildings are essential national assets that contribute significantly in economic growth, social development, and environmental sustainability. Over the years, the construction industry has experienced tremendous growth, which a lot of people or individuals or even the government invest a lot, much funds into buildings or construction of buildings. But however, most of them has been experiencing faster deterioration than expected, and some of them do collapse along the line. So these factors, some of them include material quality, construction techniques, design, maintenance, environmental factors. So we aim to predict the service life of buildings. Globally, service life prediction has been carried out by many researchers. And we want, please go back. It has been carried out by many. Hello. Okay. So we aim to predict the service life of buildings in Ghana, focusing only in Accra for now. Then we analyze these factors that affect the durability or the service life of these buildings in Accra. So, as I said, the construction industry has been experiencing tremendous growth, and despite that, Ghana we lack a model. Please, can we go for it? A model that we use to predict the service life of our buildings. So we have tropical climate, which is characterized by the high temperatures, high humidity, and intense sunlight. And they poses significant challenge to the durability of our buildings. And also, most times we compromise on the materials that we use in our construction. So we want to address this knowledge gap by developing a predictive model. So we develop a predictive model. All right, so this is the aims of the main objectives and the specific objectives of the study. So we examine the environmental, material, and construction-related factors affecting durability. Then we develop a model. There are already existing models, so we check these models. Then tailored in Ghana condition, we know the one that will be more efficient in Ghana's condition. Then the last thing we propose. Let's move, please. All right, so these are the research questions answering the objectives. Okay, so this is how we are going to carry out our methodology. So we collect historical data. Then also we conduct detailed building surveys to assess the current condition of the building. We use non-destructive testing like rebound hammers to check the structural integrity of the concrete, and bar scanner for the reinforcement arrangement. Then also we do environmental monitoring. All right, so as I said, there are already existing models, mathematical models that it's been developed already. So we want to check between these two factor-based models and statistical models to see the one which is more effective or cost efficient. So for the factor-based, we are going to use framework of like ISO 15686, which consider degradation factors. Then we come to the statistical models. Then we use the SPSS or Excel or even Python to build regression models. So this is the expected outcome at the end of the day. This is what we expect to do. Then the significance of the studies. All right, so at the end of everything that we do, we want to develop this model which will provide insight, effective maintenance practices. Because as Prof said, like when we look into Ghana, maintenance has been a problem even on our roads, buildings a lot. So we will just make sure policymakers will anticipate the maintenance need. Then also it will optimize maintenance costs and enhance economic viability. Okay, so as it's a project, we have been given a time frame, and this is the time frame that you use to conduct this research. And this is our budget. Thank you very much.
Thank you very much. Yeah. Thank you very much, Mr. Anthony Mensah. So there's a slight change in program. We'll take a group picture with the Vice Chancellor, and then Prof can come do the presentation. So please, you take a group picture now. Thank you. to my desk.
Okay.